Last but not least, we have Dr. Grant Schultz, who is, if you were in the lightning round sessions earlier during lunch, you will recall, is a professor. So he's going to be teaching you in class today. Grant is a professor in the Department of Civil and Environmental Engineering at Brigham University. He received his Bachelor's of Science and Master's of Science degrees in Civil Engineering from Brigham Young, and also earned his PhD in civil engineering from Texas A&M. He's a registered PE in Utah and a professional traffic operations engineer, originally from Alberta, Canada. Thank you so much, Grant. Okay. All right.
All right, so you are in your 5th hour of class today. Pretty much straight, other than that 1 hour break you had for lunch, but you were still sitting. So it's tough. It's a tough time of day to keep sitting and listening and trying to digest all of the information that you're given. I was thinking about that this afternoon. You know, when we teach a 3-credit hour course at a university, you know, a 3-credit hour course means you meet 3 times a week, 50 minutes each of those times. You throw it a couple times here and there because you take an exam or you do something there. So basically, a 3-credit hour course is 40 hours in the classroom. So, you know, we could just get it over with in a week, or you can come to these conferences and, you know, you're going to get about 1 credit hour worth of information over the course of this, assuming you pay attention through the whole thing. Stuart, sorry. Anyway, sorry, I just try to, you know, wake you up and keep you moving along here. I'm going to talk about something that is extremely interesting. And also a lot of detail. So I just first want to acknowledge the student who worked on this, Kyungmin Kim. He did a ton of work on this particular project, and I'm going to try and consolidate all that he did over the course of many months into about 20 minutes of discussion here. Also recognize Professor Mitsuru Saito. He's one of our other professors. He actually led this research, but is at a different conference or somewhere else today, so he's on there. And then Dr. Dennis Agate from our statistics department also worked with us on this. So what I'm going to do, go through your typical outline, background, need for the research, what we're doing here, the objectives, and there's essentially 2 sections that we'll talk about. There's the SSAM, the Surrogate Safety Assessment Model results, and then there's a calibration and evaluation component that ties into this. So this, you know, it kind of ties into some of the stuff that Christine was talking about, ties into, I think, what's happening in another session over here in terms of raised medians and left turns. But it all ties together, ties into access management. So the first piece to the background and the need for this is it is difficult, you know, to evaluate the impacts of access management alternatives using crash data. Now, it's not difficult as long as you have implemented that access management alternative, whatever that might happen to be, and you've got before and after data, and you can actually evaluate that. But it takes a little bit of time to get that before and after data, and sometimes our result may not be positive, and so it's nice to be able to have some sort of an idea before we go into this as to what the impact of that is going to be. So if we can do some level of conflict analysis in the field to try and get an understanding and an idea of what that impact is going to be, that could be very, very helpful. So the way that we decided to look at this and see if this was a viable alternative was through what's called the Surrogate Safety Assessment Model, which is a model that was developed by the Federal Highway Administration. It's been out there for a while. And it helps us to understand conflicts through a simulated environment. So our objective was to essentially, you know, look at what these impacts are, identify what the impact or benefit or opportunity was in using the SSAM model. The other piece to, of course, then the overall objective then to try and look at what it is that we're trying to accomplish here is to try and understand, first of all, can SSAM be used for this purpose? So we need to essentially calibrate this or look at least at some data to see if this is a possibility. Then, assuming that it is, then see if we can answer these two questions. First of all, how much safety improvement can be made when replacing a two-way left turn lane with a raised median? And then second of all, what kind of a threshold value should we input here then in terms of when we need to put a raised median in instead of a two-way left turn lane? So the surrogate safety assessment model, the SSAM model, is essentially, it works within a microsimulation environment. We have the microsimulation model itself that produces a trajectory file. Now these trajectory files, of course, are used in a lot of other situations. In addition to this, you also use them in some air quality analysis, other components of that. We analyze the trajectory file with the SSAM model, and from that we get an output of conflicts that occur within that model. Now conflicts, we could also put video cameras up and we could watch those videos of vehicles, and we can see conflicts where there almost was a crash but it just didn't happen. The good and the bad of our other analysis methods is that we have to wait till a crash actually occurs, but a lot of times there's a lot of near misses out there, and this tries to help fill that gap so we can identify where that goes. There's several models that you can utilize with the SSAM. We used the VSIM model in terms of our analysis, and so we were able to look at the model output, the SSAM outputs, and then of course there's a lot of numerical output that comes along with this as well. So I'll talk about both and how we utilize both of those in this analysis. What SSAM looks at, of course, are these, primarily the conflicts, but it's looking also at minimum time to collision, minimum post-encroachment, maximum deceleration rates, maximum speeds, speed differential, vehicle velocity change, initial deceleration rate, and then, of course, the conflict type and the conflict angle. And that conflict angle is really what determines the type of conflict that you've got. If you look over here, you've got the crossing conflicts that occur from about 85 degrees to 180. You've got lane change between about 30 and 85, and rear end conflicts that occur between 0 and 30. And so each of those conflicts is given a different color in the output of the model so that you can see what those impacts are. So we analyzed two scenarios. I'm going to talk about just one of those scenarios, and it's a good thing Frank's not in here, but Christine's still, going, there's way too much stuff on there, and there is, and I just didn't change it. But anyway, we looked at these corridors, the American Fork study sites, Main Street's Category 8, if you were in my presentation yesterday, which probably not many of you were because there wasn't very many people there. But the Category 8 is essentially, an urban, commercial type of a category. There's no raised median on this particular corridor. As you look through here, the corridor runs along, and then it has a little curve as it comes down through the city. So we broke it into two segments, the straight segment and then the curve segment. And we were able to get a VSIM model from the DOT, which was, of course, is always very helpful so that you don't have to build the whole model. But we did still have to pull in a lot of information here. We've got about between 24 and 30,000 ADT, and the overall segment's just over a mile in length. So the great thing, though, about that model we got, the good part is the model was built. The bad part is it didn't include any volumes on cross streets or driveways. So if you want to actually get a good access management model, you need to kind of know where the traffic's coming in and out of the corridor. So what Kyungmin did is actually took and identified all of the land uses up and down the corridor used trip generation to identify what the trip generation numbers were for the PM peak on those corridors, and then he assigned all those volumes to the driveways. So he did a very large traffic impact study and then incorporated that into the actual traffic volumes that were out there. In doing that, we're now able to to get a much better feel for what's happening all along the corridor with all those driveways, all the main roadways, everything included in our simulation model. So then we looked at two different objectives. First, we've got to calibrate and see if we can actually use this SSAM model. Does it make sense? Does it kind of line up with where actual crashes are occurring? So that was our first objective. So we looked at that in both a graphical method and in a theoretical numbers type method. Graphically, we're able to just plot where the crashes actually occurred versus where our conflicts occur. So if you look at the top on each of these is where the actual crashes occurred. Then you've got the red dots occurring where the conflicts were there. Where you've got more crashes occurring, you generally have more conflicts that were occurring. Same with the rear end crashes towards the intersections. And then the lane change. So, not a lot of lane change crashes, but not a lot of conflicts either until you get right up to this intersection. So graphically, they seem to line up in general form in terms of what was there. The second segment, same types of results to identify and see what was there. But then we also looked numerically to see, where those actual, numbers of conflicts were occurring versus numbers of crashes that were occurring. We developed a relation index that was just simply the number of crashes divided by the number of conflicts to see if we had general correlation, at least amongst the different conflicts, and felt like we had a pretty good, statistically, we did statistical analysis as well and found that we had, a statistical sample here in terms of conflicts and crashes occurring at the same general locations along the corridor. So then we thought, okay, we've met the first objective. We can use this model. So now let's start looking at in more detail what happens if we start playing around with the model. We change volumes, we increase volumes, find out where thresholds occur, where the numbers of conflicts kind of blow up. So those are places where we should make a change in terms of what we're trying to do. And then how can we then model a two-way left turn lane versus a raised median scenario and see how that affects our conflicts as well. So we did the same things. First of all, the graphical spatial analysis. We looked at the different segments along the corridor, looked at the different types of crashes with either a two-way left turn lane or a raised median. So in this case, this is our two-way left turn lane on the top each time, and then the raised median was the second piece to this. So we've got both crossing, rear end, and lane change crashes occurring. Do the same thing on the second portion of the second segment through the curve, just so we could kind of see what was happening with and without a raised median. Then we did the same numerical analyses to see what the impacts were, looked at our different numbers of crashes, raised versus two-way left turn lane. But then what we wanted to do is say, okay, what happens now when or if traffic volumes increase along the corridor? Right now we're in a situation where, it wasn't a real safety issue here, but it was a good opportunity for us to be able to identify what the different impacts were and to be able to move forward with that. So we looked at increasing our access traffic as well as our Main Street traffic. So we increased at 10% increments up to a 40% increase. Anything higher than that, the whole model just blew up because there was just too much traffic for the numbers of lanes. We didn't ever change lanes configurations, just looking at the conflicts. And then we took the results of that, going from these crossing or the two different segments with the two-way left turn lane versus the raised median, And we did a three-dimensional kind of a heat map so that we could see where those numbers of conflicts started to grow considerably. The three-dimensional graph was really cool. Frank said never put a three-dimensional graph in here. This is a different kind of three-dimensional graph because it's actually X, Y, Z, where we actually have three variables here. But we still couldn't really see a lot there till we just did an overview where we looked on top of that map to see where these heat, where the colors change because we've got such a high increase in numbers of conflicts. And in this piece, at this point, this is somewhat subjective in terms of what we were doing, but we're trying to basically identify, well, where does that color change? The blues mean that we don't really have a lot of conflicts occurring. The reds, we've got, real problems happening here. So we picked the kind of the cyan color as our threshold value of, all right, when we get to that point, our numbers of conflicts are such that we should be looking at a different treatment along our corridor. Then we ran a statistical analysis of that as well to identify what the impacts are. We included a variety of different variables. In the model, median type was always our most statistically significant model variable in the model in terms of identifying the numbers of conflicts. And others, rear end, lane change, total. There were similar trends in all of these different variables, as median was the most important variable. So we went back to those heat maps, looked at our thresholds. So we saw, in segment 1, contour maps, they're all dark blue, so dark blue is okay. We don't have a real problem there. When we start to see that changing, though, we again identified this cyan color as our border that we were going to utilize. Now, probably we could have shifted it down a layer or two, and I'll kind of show you what the results were here. But this is the point where we really have a lot of conflicts occurring and we need to change that median type. So in doing that, what we did then is identify where that line was. Then we were able to calculate, based on the volumes that were on that line essentially, multiply that through by the numbers of lanes and the general ADT ratio of about 9%. Could go up to 10% in terms of your K factors, your percentage of traffic occurring during the peak hour, and came up with a threshold of about 34,000 vehicles per day where we should be transitioning for sure from a two-way left turn lane to a raised median. Now, I've done other research in the past where our threshold came in a little bit lower than this, about 26,000. And again, that's where this kind of was more of a subjective of, okay, we've really bumped over into this cyan world, but really we should be changing that, I think, a little bit before we hit that 35,000 ADT value. And then the next threshold that we looked at was when we hit into that red. When we get up over about 44,000 vehicles per day, we should really even be thinking of something beyond raised median. Maybe we've got to look at grade separation, something of a higher nature. We didn't actually dig into that a whole lot, but it was interesting just to kind of to see what those results came out to be. So the conclusion of all this, number one, our first objective was to look at whether this was a useful tool, something that could be utilized here. We felt that it was. The SSAM met our tests that we gave it, at least in terms of the comparison between conflicts and actual crashes as a tool to be able to utilize. So then the next alternative was to look at the safety impacts. When should we be replacing this two-way left turn lane with the raised median? And of course, this is only one corridor. It's got specific characteristics. It has, quite a few driveways. I don't remember exactly what the driveway density was, but we had a lot of driveways, a lot of volume coming in and out. So that's going to change a little bit on, different scenarios that you might look at. just to kind of finish up before we answer any questions, this research was funded by the Utah Department of Transportation as part of our efforts to look at some of the impacts of access management. If you were in my session yesterday, I explained there that the next step in this, of course, would be to look at more corridors, identify more alternatives, what we can do moving forward. But I'll give you the same answer I gave there yesterday, was that the access management manager for the Utah Department of Transportation took a job with the Airport Authority. And so we lost our champion from the DOT, and so now we're looking for a new champion in the DOT that we can take this forward in. So if any of you want to move to Utah and become the champion at the Utah Department of Transportation, we can do some more work up there on this. But it has, it's a lot of very interesting article or information. It was just published this year in the Transportation Research Record, so you can get the full research paper there. And somehow, when you get into these controversial type things, a little more controversial, I guess, they make interesting news. So if you go back about 2 or 3 weeks ago, I was on 3 different television stations, radio, and our local BYU news talking about this. And the way they interpreted it was that researchers are telling them, no more left turns, we're going to eliminate them all. So the news can be interesting, but they interpret things very differently. But, it made for some fun discussions. So anyway, with that, I will take any questions you might have and try to get you out to your break early. That's always my goal. We'll get the microphone. Okay, if I can remember. Okay, so the question is whether or not the model can or will or could account for different levels of development along the corridor. Yes, it could. My, of course, caveat that we always put in here for research projects is that this is specific to that corridor under those volume conditions, and we would have to look at other alternatives. But the way the model is built, if you had any corridor that you had a VSIM model for, you can run the SSAM model with the trajectory file outputs and look at what the impacts are and then adjust those volumes. That's what we did here. We just grew the volumes on the side streets and the main line and just looked for where those threshold values hit. So that's kind of one of the big things we were trying to look at with this is, rather than build it and wait 3 years and see how many crashes we have, can we use this type of a model to vary traffic volumes and see, based on those conflicts, how volumes would, how that would affect it? Gary?
But wouldn't the answer be, I'm looking at the thresholds for yours, thinking of the thresholds on Bonison's old research on when to build the median and when not, and thinking back to 1992 when Florida DOT just said, well, when we have a 4-lane road, the chances of it being less than 20,000 vehicles a day is hardly anything. So every time we build a 4-lane road, we're going to put a median on it. Kind of the end of the story there. I mean,
So Gary's question is, why did you do this? Oh, okay, sorry. I misunderstood.
No, it further, I mean, you should build a median to begin with, even if it's going to be less. Go through the troubles that you would have to with the businesses, rather than say, whoa, okay, it's 37,000 vehicles now, let's put the median in,
Yeah.
and then deal with it.
So Gary's question is, shouldn't you just be a little more proactive, put the raised median in to start with, and then you don't have to deal with the property owners later?
Yeah.
So most states in the United States of America, and I'm from Canada, and we do things a lot differently there, eh? But, that raised median thing, as many of us know, is a pretty tough sell, but if we can show from a safety perspective that at least at this criteria we need to have that raised median, then hopefully it gives us a better fight on the retrofit side. In the state of Utah, we don't put raised medians in off the bat, and it's still a battle when their volumes get higher, because there's still that, you're going to destroy my business, we're going to go out of business, you can't have that there. Even though we have done economic studies also in Utah with Utah data and shown that's not the case, it's still a political challenge. Phil?
Did I miss something that in the model? Are you also looking at severity? So are you will the model distinguish between higher severity, like left turn related, and lower severity, as well as speed, which is a component of severity of the accident?
So the question is, did we look at severity of crashes along with just total crashes and what was there?
Speed, like if you took the model and said 35, 45, how that would change your model?
And speed as well. So we did not adjust the speed of the variables or of the model, the corridor. And the way that we didn't look at, SSAM won't identify severity, but it looks at the different types of conflicts. So we assume that the crossing conflict are the more severe, so that's what we focused more in on.
You gave it a different weight.
Yeah. Hugo.
Typically for the simulation, you will need to do some calibration. So I don't know, before you do the entire corridor simulation and use SSAM model to estimate the number of conflicts, did you, I don't know, have you done anything like maybe intersection with small segments and to calibrate number of conflicts with field observation? So I will say that will be make it more complicated.
Yeah, so the question is, did you calibrate the model in terms of looking at numbers of conflicts and how that compares with actual numbers of conflicts through field observation? The answer is no. We didn't do a conflict calibration study. What we did was we looked at the clustering of the conflicts compared to actual crashes, making the assumption that if we have more conflicts in an area, the probability of having at least a crash in that area is higher. So if those clusters matched up generally with the actual crash locations, we went from there. And then the other piece to this too is, being a research project, we were looking at, what happens from scenario A to scenario B to scenario C and D. So we weren't quite as concerned about exact calibration in terms of the volume side of things, but definitely on those conflicts. Jim.
Keeping with your theme, I hope this is not going to be on the exam because I forgot. Did you say what the speed was in this corridor?
The question was, what was the speed in this corridor? And I don't think I said, but I think I do have it here. I think it was 35, but yeah, so it varied in there from 30 to 35. We did not do an 85th percentile speed, though. We just went off posted speed.
So this is a relatively low-speed environment for this type of road. I would expect, or postulate, that maybe that threshold would go down if you were on a road with a higher speed.
Correct. So the postulation is that this might be different on a higher speed roadway. This is a 30 to 35 mile an hour roadway. Yes, that goes back to my disclaimer that this is for this particular roadway under these exact conditions, and you should hire us to look at all of your roadways under your conditions to give more exact answers.
And do it every year.
Yes. Well, I don't know if I can keep up every year. Maybe every 2 years. Right, yeah, well, yeah, okay. Weekend, morning peak, evening peak, off peak, whatever works best for you. Those are my consulting years. I was a consultant for 7 years also, so I'm good at finding other work to do.
Yeah, I'm impressed that you stay within time and had a sales pitch today. So
Awesome.
I think we have room for maybe one more question if anybody else has one.
But then we won't get out early. I promised them. I never let my students
Yeah.
out early, but I always let people in conferences out early.
Well, because you're doing sales pitches to them, right? So you
Oh,
really
sorry.
want to butter them up there.
Phil says it's time to go. Oh,
All right, thank
do you
you
have a
all.
question in the back?
Oh,
So is this the kind of research project that, or similar to this, that should be put on sticky notes and on the board outside?
Yes. Yes.
Sales pitch.
So this is the kind of research project that we should put on a sticky note outside. Having been the research subcommittee chair for many years on this committee, I just let Stuart know what these ideas are, so we're good. All right, thank you.